the ridge, so no water sources nearby. Making a fire, so most of the time, I mean, I would say 90% of the time you will find wood in the jungle, of course. You can just carry a lighter, you can carry a matchbox, and you'll be able to kind of make a campfire. So you fire for camp or for cooking. It could be also needed for cooking. In the wet season, you could carry these gas canisters, a little bit heavier, a little bit bulky, not always easy to refill. So I didn't have too many good experiences in the past with this stuff. Much easier, cheaper, lightweight to carry, compact is your camphor. Camphor will take up any time. And typically with 500 grams of camphor, which you can buy anywhere, you can easily cook a good meal for 20 people. So that's quite manageable. Next, campfire again. So campfire you can do for the ambience. Sometimes you need a campfire to stay warm in the evening. If you go in the winter months, higher altitudes can become very, very cold, especially when you settle down at the campsite, say at 6, 7 o'clock when it gets dark. It might be very comfortable. But then by 2 a.m., 3 a.m. when it really cools down a lot, there's a good wind blowing, it can become damn cold that you really need a campfire to sleep in the forest. So here you see a nice cooking setup. So proper cooking, kind of a cooking platform in the jungle you make with 3 rocks. You take 3 rocks, big rocks, so that the height of the cooking pot is a little bit high, so that it's kind of, you can get a good flame under the cooking pot. And then you don't close it up, right? Many people, they just make it like a closed triangle or a closed 3 sides of a rectangle. But you actually have to use 3 points, 3 rocks pointing towards each other, so that there is good ventilation. I mean, otherwise you won't be able, unless you have a good airflow, oxygen coming into that wood burning in the center of these rocks, you will not get a proper fire. Many of our organizers even make this mistake. Next one again, cooking. Now this is like a typical end of the day scenes. Once we reach the campsite, we settle down. Right, a couple of tips how you make a proper cooking stuff. Next. So here, I mean, we'll talk about this a bit later. So let's go later. Here you can see, I mean, you're discovering a lot of beautiful natural. Making a lot of beautiful natural discoveries in the jungle. But on our exploration tracks also, sometimes we find a lot of interesting, not always beautiful, but interesting ancient human structures. So here you can see some religious figure. This is like a 3-meter high stone with a religious figure carved. Here you can see a British bungalow, which is somewhere on top of Tada. Here you can see an old jeep track built by the British in Venkateswara. There we find some old stone dated 1913, so exactly 100 years old. Sometimes it's very interesting to kind of discover places in the middle of nowhere. Totally, I mean, nobody goes there anymore, but in the olden days, if you go back in the olden days, right, they 100 years ago, 80 years ago, they actually built jeep tracks there and went deep inside the forest. They had beautiful forest lodges there. This is a rest house used by the British. So it's very interesting to kind of discover these old places, which of course have been completely overtaken by the jungle now. After 100 monsoon of being kind of maintained, it's converted in a total ruin sometime. Okay, so just one click now, only one click. So can somebody tell me, if you go in the jungle, what would be the #1 danger?
Water.
No, everybody seems to know.
Bee attack.
Yeah, so actually the first one will be water indeed. So I'm saying the first one because we have statistics. We have taken 15,000 people into the jungle, so we had indeed to rescue quite a few people. And you can see typical pool, very beautiful pool. This is the V6 pool, one of the most beautiful pools, again in Venkateswara National Reserve Forest. You can see this is not a swimming pool, right? So you have rocks and boulders here, so here you might be standing till here. You take one step and boom, the water goes till here. So as a non-swimmer, you might also see your friends nicely enjoying jumping, swimming in the water. And so you also get excited and want to jump in. But be careful, I mean, this nice looking pool is a death trap if you don't know how to swim properly. I cannot say this enough. It happens on many treks. that people get excited, say they see this beautiful waterfall. It's a crystal clear pool, not the Chennai Kum River. You can see 5 meters deep in the water. It's so beautiful, you can drink from this. People want to jump into that. It's cool, refreshing in the tropical climate, but it's a death trap. You need to be able to swim or take proper precautions. Use a life jacket or use a swimming tube, or it can be fatal. I'm telling you, we have rescued too many people in the past, and there have been fatalities. There have been fatalities in the chase, for which we could, which we were collecting 100 rupees here. Chase actually jumped in one of the pools. Supposed to be a good swimmer, he was swimming for 50 meters. He suddenly became in trouble. He actually was swimming with his jeans pants. Big mistake. He was swimming also in the water, I guess, in the morning, even before warming up trekking. So I think the difference between warm body heat and cold water would have caused some cramps or so. So be very careful. Don't think too quickly you're a good swimmer, because it's not a swimming pool, right? It's like a thing. There are some currents there and stuff. So always be careful. Make sure there's a proper solid swimmer around, and that you're using a tube or a rope or whatever. So water, be very careful, people. I cannot say this more enough, because if you go down, your friends, your family are left behind. Number 2. So what is the second one? Don't click on the picture. So what would be the second one? I'm talking statistics here. 15,000 people. What is the number 2 thing that we have seen statistically? I mean, I'm not thinking this is it, but this has been proven. Bees are there, but bees will not be on number 2.
Say fire originating out of campfire and cooking.
Now, fire spreading like wildfires, that's a possibility, but
coming out of cooking and campfire.
yeah, I mean, fire spreading uncontrolled, you say, that could be a possibility, but never had any trouble with that. Typically, fire doesn't spread that easily. Insects and animals, snakes, not nowhere in the top 3. Rocks, exactly. Next picture will show you why. It's my picture. Click. Boom, what do we see here? So we don't see a big rock here, we see a very small rock. Right, so we're climbing uphill somewhere. Actually, I made a mistake, we should not climb vertical, we should always climb on an incline. Somebody 10 meters on top of me kicks down a little rock. Rock, not a big deal. I can throw this rock on you, nothing will happen. Only problem is that rock, of course, gains a little bit of speed and energy after going down for 10 meters, of course, and then it looks much worse than it is actually, but there's a bit of a cut in the forehead. The head always bleeds a lot, so it looks a little uglier than it is. But again, statistically speaking, we're lucky a couple of times. Not with small rocks in, but when climbing up a slope, climbing up not a ridge, not a valley, but climbing up a slope, somebody kicks down the rock. That's fine, as long as you're close, as long as you're like going in a 45-degree, the rock will come down. But if everyone is walking on a line 90 degrees up, right, the rock comes towards the next person. And if there's a distance of 10 meters between that person who kicks the rocks and the next one, the impact is going to be huge, right? It's like energy increases like with some squares as the distance and the speed increases. Okay, number 3, it's like a quiz. That was two clicks. So indeed, the bees. This is something that we actually didn't have trouble with in the past, but in recent years, like the last 1 year, we have had quite a few bee encounters. So again, bees by default, they are not really aggressive, just like other wildlife, they are not going to make the first step. But again, as you go in this jungle and you don't always see what's ahead of you, sometimes you might be somewhere close to a hive that those bees get alarmed, sometimes people make noise, sometimes we cook, there's smoke going to a hive which is hanging a little above. So bees can be dangerous. A single bee sting is not a problem. But if you come under a heavier bee attack where you get 100 poisonous bites, the amount of poison in your body can become quite tricky. So we have had to kind of get people out of the jungle sometimes. I hope the kids won't become too scared. Are dangerous, but at the same time people forget that rocks which are wet are very slippery. You have different shoes, different brands, everyone will say vitamin sole, this sole, that sole. If the rock is really glibbery and wet, if that waterfall is running here throughout the year, there is constant 365 days this rock is wet, it will, like algae, it will become very slippery and it's sometimes tricky. So be always careful stepping on wet rocks near the stream. This guy was, you don't see it in the photo, but this guy was about to fall down quite a bit. So we had to pull him out. Next. Once in a while it also happens, right? I mean, what I show here, I don't want to scare you. I mean, this is the reality of life. But at the same time, this doesn't happen every weekend. So this happened once, like 2 years ago. Reggie from Bangalore, he slipped down some rock. He kind of went down quite some, I mean, not vertical, but like a slope. He kind of hit with his foot against some other rock and kind of had like a fracture in his foot. So he was not able to walk anymore. So again, it took us quite a bit of effort to get him out, first on the shoulder. Once we reached the valley next to the stream on some jeep track, we had to make like a makeshift carrier to kind of carry him out. I hope I'm not putting everyone in shock here, but I want to give you a balanced view, right? I cannot show you the beautiful pictures of the waterfall. At the same time, I have to warn you about all the risks involved. So one more reason, go out with an experienced group, don't just venture out by yourself with a couple of friends. Part 6, where am I? This is all going to be about GPS and navigation. So how do we navigate now? We have the map. We have seen a lot of things about the terrain, what are all the key terrain features. We know what to carry with us. We have seen what are the dangers, what are the challenges. Now let's talk a little bit about navigation and GPS. Okay, so this is again a little more technical, but I mean, if you're serious about going out, it doesn't have to be a trek, it could be a cycle trip, a bike trip. If you go out off the tar road, if you go in the outdoors, you need to kind of navigate by yourself, you're on your own. GPS, so what is GPS? GPS, I guess many of you know because of the fact that many of today's smartphones have a GPS receiver built in. GPS stands, click for Global Positioning System. You can click a couple of times. Click, click, click. Click one more time, I stop. So GPS is actually something that was developed by the United States, the DoD, Department of Defense. So and it's basically a constellation of satellites. So they have launched like satellites from the early 60s, 70s. Typically over the decades, there are new generations of satellites. So they have launched several different batches of technology, and right now there are still 30 satellites operational from 3 different batches. So there are 30 satellites which are moving around the Earth. Right, so say this blue spot is you. So you're here with your smartphone or with your GPS, right? You're on planet Earth. You know, all of us know that planet Earth is spinning around, right? So you are spinning, the satellites are spinning. So as you spin it, it's going to be a different number of satellites at that moment of time. There will be a different number of satellites that you're able to see or that you're able to receive. They're basically picking up a satellite signal with this GPS receiver. So the number of satellites will typically be between 6 to 12 satellites. They will not be visible, but your GPS receiver inside, say your phone or whatever it is, it will pick up a signal, strong signal, weak signal, depending where the satellite is. Depending whether there is something in between you and the satellite, some building or some jungle. So, next slide. So, basically, that you with your GPS receiver here, you will have to have a clear view to at least 3 satellites to kind of what they call triangulate your position. It's a little bit technical. I don't want to go too much into that. But unless you get like a clear view, like a signal or lock basically of your receiver with those minimum 3 satellites, you're not going to get a proper fix of your location. If you go to the next one. So now let's talk a little when we talk about location, right? So with your GPS receiver, you will be able to kind of you will be able to identify your exact location on wherever it is, anywhere on planet Earth at least. When you take a space shuttle to Mars, you'll need something else. But on planet Earth, GPS will allow you to identify your location. So what do we mean with location? Let's say, for example, Chennai here. So how do we define now the position of Chennai or the position of some place in Egypt or some place in Europe there? So position, as I already told, like a couple of slides back, will be determined by 2 things, a latitude and a longitude. So I'll just explain you what it means now. So latitude, let's start with longitude. So you know, planet Earth is like a sphere. It's not a perfect sphere as we know. It's more like a potato or a squash sphere because of the rotation and everything. But it's more or less like a ball. If you go around this ball, obviously, say for example you're following the equator, you're going along the equator, you're taking a circle around the Earth, it will be like 40,000 kilometers. 40,000 kilometers, and at the same time, in basic mathematics, you will be covering like 360 degrees, right? One circle consists of 360 degrees. So what they have done is actually, they have divided this equator, this circle, in 360 degrees. So when I say divide means, you have a point here, and basically you will draw a line from the North Pole, it will go to the equator, and it will go to the South Pole. So that's what they call the longitude, or one of these 360 degrees. So we just now need to fix where we start. So the guys who introduced the system are the British guys, so obviously they took London as a reference. So the circle that goes through London is considered 0 degrees. If you go to the right side of London towards east, you go into eastern longitude, you'll have 180 degrees east of London. If you go to the west, you're going 180 degrees west longitude. So that's how they use it. London as a reference point. If you go to Europe, to Asia, you're going east. If you go to North America, South America, you're going west. So if you look at India, so London is 0, you can see here east 30, 40, 50, 60, 70, 80, 90, it will go all the way around till 180. Then it will go west 180 to 0, so total 360 degrees. So if you look at Chennai somewhere, Chennai is between 70 and 90. So Chennai is actually pretty close to the 80 degrees east. Chennai is located 80 degrees east of London. So that's this line here, this longitude. Okay, now thanks. So this all the places on this thing, right from the North Pole all the way to the South Pole, are like called east 180 degrees in this case. So this gives you actually the horizontal position. Now you also have to kind of fix the vertical position. So these vertical circles that you see here are what we call latitudes. So again, starting from the equator now, equator is 0, 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50, 60, and the North Pole will be 90, right? You're going from here till like 1/4 up is 90 degrees north. Same thing, going down the equator, you're going 90 degrees south. Okay, so now Chennai is going to be 80 degrees east, and if you can see here we have 10 degrees north, latitude 20 degrees north, so Chennai is somewhere here, so Chennai is around 13 degrees north latitude. So Chennai is uniquely identified by east 80 degrees and north 13 degrees. I hope everyone is clear on this one, because that's fundamental. I mean, every map, every GPS is going to use latitudes and longitudes to correlate your position in the jungle with your position on the map. If we go to the next one now, so yeah, we can click a bit somewhere for a couple of numbers here. So just a small calculation here. This is a little mathematical, but I think it's anyway interesting to know for people who are interested. So I told you, if you go around the equator, you cover 40,000 kilometers. Again, the British don't work with a metric system, they work with imperials. So they use miles. When I say mile, 2 miles, you have a land mile, 1,609 meters, and you have a nautical mile. Nautical mile is 1,852 meters. And so here in this case they have used nautical miles. So 40,000 kilometers is equal to around 21,598 miles, nautical miles, if you divide it in 1 by 1.8. So that circle that we draw, that longitude, right, 360 degrees of your equator is equal to 21,598 miles, right? 360 degrees equal to 21,000 miles. So if you divide by 360 to know what is 1 degree, 1 degree will be 60 miles. So now you can already see, right? So if you divide this by 360, you come to 60 miles. If you can divide this by 60, 1 degree is 60 minutes. 1 minute is equal to 1 mile. So that's how the British have defined a nautical mile. Nautical mile equals to 1 minute. in this latitude, longitude measurement system. Okay, and if you click on Saba, you will have 1 second, so 1 minute consists of 60 seconds. So if you divide 1,852 meters divided by 60, and then you come somewhere around 31 meters. So if you look at maps, if you look at GPS, you're never going to see meters or miles, you're going to see seconds and minutes and degrees. So it's very important that you understand that 1 second is 30 meters, from here to there, 1 second, and that 1 minute, 1 mile basically, 1,800 meters. Keep that in mind. Next one. Okay, georeference. So what does it mean, georeferencing a map? Georeferencing a map, we have seen a lot of maps. Many times you just look at a map, but the map is only useful if you know where is this place. So where is this place means that you need to know the latitude and the longitude of every place on this map. So what we do is basically we georeference a map. Georeference basically means you draw a grid. Let's say, for example, let's take a peak here as an example. So we have this peak again. Yeah, this is like a peak. Well, I think it's Jungle Beta. So this peak, what is the location? I can now say the unique location. This peak is located at, here it's 77 degrees, 32 minutes and 45 seconds east, and vertical above the equator, it's north 10 degrees, 15 seconds and, 15 minutes and 0 seconds. So using this north and east, latitude and longitude, basically you can uniquely describe any position on planet Earth and find the same place back correctly on any map. So that's very important to correlate the real world with the maps. Next one. Next. This is like a low-end device. This is an E-Tex. I think it's $100 US. We typically get it in the US because in India it's a little expensive. It's import duty. It's best to ask a friend who is traveling to the US to bring it over. This will be 5,000–6,000 rupees for a base unit. And in CTC we use, if you go to the previous screen, one little back, Saba 1 and one more. So we mostly use this unit. So this is a little bigger unit. And it supports downloading of maps in an easier way. And it also has a bit of a bigger antenna, so it's giving a better signal reception. This is the GPS map. This is an old model. Now we use the GPS map 62, which is around $300 US. It's a little expensive, but as a trekking group like you guys, it's definitely a worth investment, because without that GPS, you will have your map, you will know I'm here, but if you're in a valley, you don't have a clear view. Unless you have a GPS, you don't have a clue where you exactly are. So that GPS, or in case of some good visibility, if we go to the next slide, you can also use a compass. Next one. So this is cheap, 60 rupees, but it's a little bit challenging, of course, because if you're walking in valleys or in dense jungle, compass is not going to be very useful, except for saying, okay, I'm going in 15 degrees northeast or something. You won't really know your exact position, because in the forest, most of the time, I'm telling you, there's very little visibility unless you're going to climb on a peak every time to get kind of a fix of your position. So compass is useful if you have an open view. So say, for example, we have this compass. If you buy a compass, get something like this. Don't get like a cheap thing. A good compass has like this viewpoint here. You'll have a metal thread that allows you to kind of point it exactly at the right direction, bearing. And it will also have a magnification glass that will allow you to look and read the bearing. Your bearing means north is 0 degrees. Go to the east is 90 degrees, south is 180 degrees, west is 270 degrees, and again you're completing the full circle 360 degrees. So compass basically shows you, right, whether you're going north or whether you're going 45 degrees towards north, towards east. So it shows you your direction, your bearing. So how does this bugger here knows where he is? So what does he do is he picks a reference point. So say some peak, or say some electricity post, or anything that stands out in the terrain and that you can correlate on the map. So he's basically here looking at a certain peak here on the topo map. You can see again we have a little one in a circle here, a peak. So he's pointing his compass, so he's actually looking, a little bit of a weird thing, it's more like a mirror here, but normally he's going to look at that peak, looking through that thread. So he's going to put the compass on his flat end, he's going to look exactly through that metal wire and make sure it's exactly hitting the peak. And then he's going to read through this magnification glass, what is the bearing. So in this case, I think it's somewhere like 46 degrees, it's not visible here. So once he knows that he's at a 46 degrees bearing from that peak, he can draw that same 46 degrees on the map. So he can make a line through this peak at 46 degrees, so actually the inverse, right? Because this is north 0 degrees, here it's 46 degrees. So this of course is the opposite. So 46 degrees, you draw a line here. So he knows I'm somewhere along this line because I see this peak at 46 degrees. And then you already know what he's going to do next. He's going to take another reference point, some other peak here. A second peak, which is clearly visible on the map and the terrain. Again, he will take his bearings at 320, 80 degrees. Then we have 0 degrees, 90 degrees, 180, 270, and here somewhere 328, yeah. So from this position, he's looking at this peak on this map here at 360, 328. So he's drawing another line, 328. And of course, the crossing of the intersection of both lines gives you approximate position again, depending on how accurately, that's why I'm saying, that's why we have the magnification glass and the metal thread here, so that you kind of have an accurate angle and an accurate reading. The more accurate, the more proper your position will be defined. Okay, next. Okay, now this is interesting, I think. So, hey, say you get a GPS, your friend brings you that nice GPS map 62 from US. Whoa, cool, ready to go in the jungle. You switch on the GPS, you get your, whoa, cool, I see my latitude, my longitude, yo, I know where I am. Right, so then you go to the map screen, if you go a little back somewhere, that map screen here, little back. Yeah, so you're looking for this map screen. So what you're going to see in there is it's going to be blank. So GPS you got, Norway is going to come with the maps for India. Only when you go in the US or Europe, you will get proper contour maps.